Hey guys, sorry I'm checking in so late today. Just been really thinking about what we are going to do for the next 2 months for you guys, so thanks for being patient. All right, we're going to do Tuesday on our math review for number 28. So 28 is our number that we're going to focus on for number 1. We're going to find prime factors. So remember, we need to know the word factors, and then we need to look for ones that are prime. So factors are two numbers that multiply together to give you a product. Our product that we're focusing on is 28. So I know 1 times 28 is 28. I'm working in the windowsill. Thought maybe it would be good lighting, but I don't know. 2 times 14 equals 28. Does anyone think of 3 times anything? 3 times 7 is 21. 3 times 8 is 24. 3 times 9 is 27. 3 times 10, so that won't work. Let's do 4. 4 times something equals 28. I know 4 times 7 is 28. 5 won't work. 6, and we've already doing 7. So let's just stop there. Let's look at what we have. So I know 1 is neither. I'm sorry, the lighting. 1 is neither. 28 is composite, obviously, because we're finding factors. 2 is prime. It can only be made with 1 times 2. 14 is composite. It can be made with 1 times 14 and 2 times 7. 4 is composite. It can be made with 1 times 4 and 2 times 2. And then 7 is prime. It can only be made with 1 times 7. So if I did that correctly, for Tuesday, the prime factors are going to be 2 and 7. Okay, everybody with me? If I missed any factors, you guys just let me know in the comments, okay? All right, number 2 says we're going to find the pattern below if we were to continue this current pattern. So I'm going to write out the pattern that is shown here. So we have 114, 111, 107, 102. And we are looking for the 8th number in the pattern. Okay, so here are the numbers. And I am going to mark out the pattern so that we can find the 8th one. I'm going to move. Thanks for being patient with me. I'm going to move over here on the floor. I think it would actually be better for me. Thanks, guys, for being so flexible. Sometimes things work and sometimes they don't. All right. So the first thing we need to do is we need to figure out the pattern that's happening as we go from one number to the next. So I am noticing that as I'm going through my pattern, my numbers are decreasing. So this is a decreasing pattern. They're lowering in value. So I know that I need to focus in on 2 operations that decrease a pattern, so subtracting or division. So if I look, it looks like they're subtracting 4. No, I'm sorry. Looks like they're subtracting 3 to go from 114 to 111. And then it looks like they're subtracting 4. 11 take away 4 is 7. And then 7 take away 5 is 2. So it looks like it's decreasing by 1 more each time. Does that make sense? Let me show you what I mean by that. So 114 minus 3 gives me 111. If I take 4 from 111, I get 107. If I take 5, I get 102. So it looks like each time it's decreasing by 1 more than the other. So let's just continue that pattern. So 102 take away 6. Okay, should be 96. Okay, then 96 take away 7 should be 89. 89 take away 8 is 81. And 81 take away 9. Did everyone see what I did there? I'll scoot back so you can see the pattern. So it looks like the 8th number, so notice I put the pattern out 1, 2, 3, 4, 5, 6, 7, 8. The 8th number in the pattern would be 72. Perfect. So I'm going to go ahead and find 72. Awesome, there it is. All right, great job, guys. Number 3, Pete is going on a trip. He has to drive a total of 823 miles. I'm going to write that down. If he drives 24 miles a day, how many days will it take him to get to his destination? So we're looking for days. So it looks like we have a total. And we need to divide that total up with 24 miles per day to figure out how many total days that would take. All right, so we are going to need our multiples of 24. It's going to be a tough one. 24 plus 24, 48. 48 plus 24. I'm actually doing my multiples over here because I don't have my calculator, so just so you know, you can do your multiples of 24 on the side even if you don't have a calculator. So that gives me 72. And then I get to 96. So I'm going to stop right there because I know 24 cannot go into 8, but 24 can go into 82 1, 2, 3 times without going over. So I'm going to subtract 72 from 82. I'm going to get 10, and then I'm going to bring down the next number. Okay, and I'm going to add another 24 just so that you guys can see the multiples here. So 24 times 1, 2, 3, 4, 5. The 5th one is going to be too big because I only need 103 miles. So I'm going to choose 24 times 4. It's going to give me 96. And that is going to leave me with 7 miles. Now, this problem is a really good problem for us in 5th grade because he has a total number of miles that he's going to travel, and he can only travel 24 miles each day. So, if he does that for 34 days, he's going to travel all of these miles, except he's going to have 7 miles left over to still get to his destination. What do you think that we're going to need to do? If you said that he is actually going to need to drive for 35 days, you are actually correct because the total amount of miles he can travel is 24. And then he has this amount left over. He's not just going to throw that amount away and just pretend that he's already at his destination. He still has 7 more miles to go. So we're actually going to need to add an extra day in for him to accomplish those 7 miles at the end of his trip. So he is going to actually need 35 days, not 34, in order to accomplish all 823 miles if he's only driving 24 miles a day. So this problem is one that we've talked about when we interpret a remainder. Meaning the remainder of miles is not just thrown away or left over. We actually are going to need to add another day into our trip in order to make sure we get all the miles taken care of. Great job, guys. All right, we're going to go to our number 4. Number 4 is an elapsed time problem. It says Tom left his house at the time shown on the clock. So we're going to need to read a clock together. He was gone for 8 hours, 22 minutes. What time did he get home? So I want you to set up a wonderful number line on your paper. We're going to read the clock together. So the hour hand is in between the 1 and the 2. It's not quite 2 yet. So that tells me that it's still 1 o'clock. And the minute hand is on 10. So let's count by 5 so we get all the way over there. 5, 10, 15, 20, 25, 30, 35, 40, 45, 50. It's 1:50 when he leaves his house. So on our number line, we're going to put 1:50 at the beginning because that's when he leaves. They want to know what time he's going to get home. So that is the end of the number line. And then the elapsed time, or how long he was gone, is 8 hours, 22 minutes. Are you with me so far? All right. I'm going to do a really big jump. Are you ready? I'm going to jump all 8 hours because I know 1 plus 8 is 9, and my minutes don't change right now. Not yet. Look what Miss Conley did. I got them over with right away. All right, now I'm going to address the 22 minutes that I have left. I'm going to jump 10 of those 22. Why? Because it's going to get me to 10 o'clock. It's going to get me to the next whole hour. And then I'm going to make sure I note that I took 10 away from 22. So I'll have 12 minutes left to jump. And then I'm going to do my final jump, which is 12 minutes. 10 plus 12 minutes, it's 10:12. Let's write it. Sorry, the lighting is so bad today, guys. All right, so that means that he left. He was gone for 8 hours and 22 minutes, and now he is back home at 10:12. I'm going to show you the number line one last time because the lighting was somewhat off there. And there we are. Awesome. All right, we're going to use our last strategy to do number 5. This is one of those ordering decimal problems. This one says we are going to order least to greatest. Least to greatest. So I rewrote this on my paper, least to greatest, so I know. Now what I'm going to do is I'm going to stack my decimals. Remember, I used this strategy yesterday. I lined up the place value, and I lined up the decimal point. Do you remember what strategy I told you yesterday that you could do to fill in the empty spaces? If you remember to put 0, your placeholder, in the empty spots, you are correct. All right, let's look for the least, since we're going to order from least to greatest. So let's look at the whole number spot. They all have a 0. Let's look at the 10th place. They all have a 4. So let's move over to the 100th place. I have 0, 1, and 6. I'm going to focus in on the 0 since that's the least. And then I'm going to look at these two numbers. And I'm going to focus in now on the thousandths place, because everything is the same until I get to the thousandths place. Let's think about 400 thousandths or 406. Which one's smaller? Hopefully you said 400 thousandths, or it is represented by 4/10 in our problem. They are the same. So I'm going to put that over there. And then I'm going to put right in front of it. I'm going to put those zeros there so you see where that came from. So 400 is smaller, and then 406 is a little bit bigger. Okay, now let's compare what we have next. Let's just look at the whole value. 460 thousandths or 416 thousandths. What's smaller? I think 416 is much smaller than 460. So I'm going to go ahead and add 416 there. And then my greatest value there. And if you really think about it, 400 is smaller than 406. 406 is smaller than 416. And 416 is smaller than 460. So there is your ordering from least to greatest. If you want to do it right here on your sheet, you'll have it written like so. And there they are from least to greatest. Great job today. Thank you guys for being so patient with my video. The light from the window was not working with us in the beginning, so thanks for staying with me while we transitioned over here. I will stay in touch with you guys tomorrow, okay? Stay safe and healthy. Love you and miss you.